Hi, today we're going to start with what should be a very simple job. It's going to be a MacBook Air board that has no backlight, and when you look at the board it should be really obvious why. So let's see what I got here on the microscope camera. And yeah, burned, red probe points. You're also going to see by the LED driver that, yeah, red. Now under the chip looks healthy, which is a good thing. So I do have a healthy feedback wall there. So I have discussed in other videos how if the feedback is not connected, how it's not going to work properly. So the first thing we're going to do is we're going to replace the LCD connector on here. This is not an LVDS connector. This is DisplayPort, since it is an Air. And the Airs do not use screens that use LVDS. So we're going to take the hot air station here. Going to turn up the heat a little bit. Now, one of the things about the hot air, you see how the chip right over here, this chip I'm 99% sure is Thunderbolt and DisplayPort. We don't want to reflow that, so I'm going to point my hot air in a direction where I'm not going to be blowing the hot air over it, because I don't want to screw things up that don't need to be screwed up. So one of the issues with the Air that some people get themselves into is that they mess up the DisplayPort and Thunderbolt circuitry when they remove the LCD connector, because they're blowing the air the wrong way and they reflow or they fuck up that chip. And that's something we want to avoid doing, because it decreases our ability to collect money at the end. You can see here I'm heating the hell out of this old connector. I don't necessarily really care if it gets destroyed, because I am replacing it. So my hot air station has very intermittent heat compared to what it used to have. So that's something that I gotta look into fixing. So then after that, we're going to take my iron, which is going to beep in a second, like it always does. I can't stand that beeping. And we're going to clean the old board, which means turning on my fume extractor so that I don't get cancer. Because you guys know, as I've stated in some other videos, I really don't want to get cancer. It's not on my bucket list. So make sure that is where it's supposed to be. And we're going to start cleaning. So before we start the cleaning process, I'm going to put a little bit of flux on the board to help the solder flow. This is Amtech 559. Hopefully you can even hear me between my air conditioner, the fume extractor, the computer fans. I'm surprised. The hot air station, you really can't hear anything here. I can barely hear my own damn voice. So let's get started. So I'm going to run this solder over here. Fucking fly. I'm gonna piece of shit. Oh, I'm gonna. Now that is pretty nasty. We're gonna have to run a jumper wire there, most likely. Let's just take a look. Get an idea of what we're up against. So this is obviously pad for LCD backlight, and that doesn't look any good. It's already old. You saw how hard it was to get anything up on the board in that section. That was because that, got destroyed and burned. So I'm going to be running a wire for that. I don't want to trust that that's actually going to work and conduct electricity. So that piece of board that looks nasty, we're just going to take it. And goodbye. Get out of here. Come on. I don't want that. See, the thing is, I don't want that piece potentially burning itself into the board and touching ground in a manner where I can't separate it, or in a manner where I have to do more work later. Because that does happen a lot. And you get a little hole in the board in that section, and then it winds up spreading, and ugh. No, thank you. So one of the things I'm going to do now is with my multimeter is I want to check and make sure that there is no short to ground, because I would be surprised if there was not a short to ground at this point. So let's get the multimeter on the table. I'm going to put this in diode mode. Zoom in on it so you can actually see it. Damn, this office is too bright. You put this at the right angle, you can't read a damn thing. There we go. A little bit more zoom. So we take the red probe and we put it on grounds. So you're going to use one of the pieces of metal by the screw hole here, and then the other probe on the output of backlight. And there's no short to ground. So on an LP8550 base board, anywhere from 0.519 to 0.546 is usually in the range of what you're looking for. So that's good. I'm happy with that. I'm set. And with that being said, time for me to get to work with cleaning and putting on a new connector. So the wick that I use is called Goot wick. We like to joke around here, since there's a bunch of Chinese stickers on it, that is, you know, some Chinese manufacturer's misspelling of good wick, or mispronunciation, misspelling. I know, we're not funny. But corny jokes help the day go by. So I put some flux on the board just to assist with removing the old junky solder. If you run the wick across like so, and if you use good wick like Goot wick, it removes everything and makes you look like you're better than you are. That's the thing about good tools. They make you look smarter and better and everything than what you actually are. And that's exactly what I need. I want tools that are going to make me look like a genius even when I'm a moron. So one of the things I just did, which you should never do, but luckily I was on a ground pad, is pick up the wick. You want to kind of drag the wick along by the wick while you're pressing down with the iron. You don't want to actually like take the heat away and then move the wick, because you know exactly what's going to happen there. You're going to do that, and then the pad is going to come off with it because it's going to have a chance to cool down. All right. We've gone through there, and I'm fairly satisfied that that is clean. Now, let's just get rid of some of the, so that I can lay a connector down flat on the board. This is a board that has holes in it, which means aligning this is going to be very, very easy. There's a hair on there, but friggin' Q-tip. I left my brush in the other room. I could either pick up the brush or I could get rid of this little hair, particle, whatever. That's the thing a lot of people talk about. Like, there was this one troll in some other video that's going, you know, you should use a brush, not a Q-tip. And it's like, you know, the brush is in the other room, but I have a Q-tip right next to me. I'm probably going to use the Q-tip. You know what I'm saying? Like, it's just a matter of efficiency. Oh, son of a bitch. These are not the connectors that have those little spokes in the bottom. Which means manual alignment. Oh. Oh, well, I'll find a way to live. So yeah, see there's these holes on the board. And when you get the right connector, that it'll actually align itself with the spokes, and it's beautiful and it's amazing. But when you don't have that, you have to do the alignment yourself, which is awful and miserable and nightmare. You'll see in a second what I'm talking about. So we take the connector and we move it into place. I hate connector soldering, by the way. This is, like, there's no brain usage in this. There's no troubleshooting. There's no thinking. This is just, you know, this is just pure manual labor, and I hate it. It's easy to solve, but it's not easy in terms of it's miserable. I hate doing connectors. Da, da, da. So I put some flux on that side on the board. I push down on the connector as hard as I can to make sure that it's actually being pushed up against the board. Now, the thing is, I don't have enough hands to do this properly. So you're supposed to always be flowing new solder. You can't just take solder and, like, you know, put it on the iron and then attach it to where you want to attach it to. That doesn't work. It burns up all the flux inside of the solder and then it doesn't flow properly. The problem is I need to hold the connector down with one hand, the iron with the other hand, and the solder with the other, which means I need a total of 3 hands. And unfortunately, I was only born with 2. So what I do is I put flux down there so that even, you know, the solder is nasty and doesn't have any flux inside of it, it will once, you know, I flow it on there. And there you go. So it's going to be stuck down there now, which means that I can now go about doing the pins one by one. Now, there are a lot of people that do the pins one by one, and they do a damn good job of it. I mean, there's even a demonstration on the Hacko website, and I've seen people that are much worse at general motherboard repair than I am doing that very, very quickly, and it's pretty impressive. And I suck at it. So if you're a troll of the channel, this is actually an excellent time to troll, because I am one of the worst connector solderers that you will find. I mean, really, this is not my thing. This is something that I am bad at. Okay, so the idea is you want to kind of do something like this. You want to, you know, go here. You have flux going down there, and you're going to put the solder over here. Now with you can actually know how to hold it without moving it all the time. It's just you'll be able to have hands that stay still, and it'll be easier. So it's not going to be like this crap that I'm trying to do here. Yeah, this is sad. So you're going to try to go along one pin at a time, like so. Now what's going to happen is probably something like that. Like where if your hand moves the way mine does and has just no ability to go where you want it to, it's just going to become a mess. So what I do is I usually wind up giving up and doing sad attempt at drag soldering. Again, I have done one pin at a time before. I've done it many times. But it's such a nightmare for me. So what I do is I have flux running all along there. I make sure that I'm touching the bottom of the board more than the pins. I do something like this. See that? And the solder that's on the iron winds up attaching itself to all the pins. It's actually better for me usually if I just put the solder on the pins instead of have it on the iron, and then just kind of drag it over. See that? This is what I like to call cheating. That's the cool thing about being a grown-up. You're allowed to cheat, and as long as you get the result that you want, you get away with it. So I have a tool that makes this easier. So if I were still using, you know, the $10 piece of shit iron that I did a video on before, if I were using that $10 iron, this would be a fucking nightmare. But because I'm using this Hacko FX951 with a 2027 and this nice curved tip. This curved tip is, by the way, very, very critical. So you may be wondering, why do I have a tip that's curved instead of those standard soldering iron tips where they're conical and they're huge at the end? That tip doesn't do shit. This curved tip, you see I want a curved tip because the whole point of the movement is something like this. That's why I want the tip that is curved, because it's going to help me with my movement. So I did that entire connector in seconds, and I required no skill. So you saw when I was trying to do it one at a time, and like how sad it is, you know, and how bad it was, and that I couldn't even get my damn hands to, you know, to get the solder by the pin without it taking me 20 seconds. But then when I cheated, I was able to do the entire connector in seconds, and it came out with, you know, those are not bad joints. I mean, really, that's the way it's supposed to be. I mean, that is, you know, just a little bit of cleanup for that ridiculous asinine amount of flux that I had on there, and it's going to look good. And, you know, I was able to align it, even though I'm not using the one where it aligns itself. So just going to, I want to get solder on both ends of that, so that's why we did that. We want solder on both ends of this, not just on one. So we're going to do something like this, since there's flux there, but an absolutely minimal amount. The reason that I want it to be a minimal amount is because I don't want solder flowing in the inside of the connector, because if it flows in the inside of the connector, then it becomes an utter nightmare to actually insert the cable in. This is not so important if you're doing this for yourself, but if you're doing board repairs for clients that are going to be reassembling these, what the client is going to do is they're going to reassemble the machine, and they're going to rip the connector off of the board, because and that's just bad. So if, you know, you can get away with messing that up a little if it's for yourself, because you'll know what you did and you'll know what you have to do to make it work. But again, if you're doing this for other people, you cannot get solder inside of there. If you get solder inside of there, just fucking redo the job. Because again, they will, it won't end well. You really have to make things idiot-proof. You have to make it so that, you know, like a 2-year-old can put the shit back together without breaking it. And that's And I cannot stress that enough. Okay, so then the next thing that I'm going to do is I want to actually go over the work and see if I messed anything up. Because keep in mind, I mean, it's not like I soldered each individual pin. I put flux, I made sure that it was making good contact and touching, and then I just dragged it all the way over very quickly in a, you know, very uncontrolled movement. So I don't have the greatest expectations. Now, as you can see, I did mess up a little bit over there. Let's just blow some of the alcohol and junk away. So we're going to fix that real quick. See what good flux does? Like, do you see what good flux does, what good tools do? I mean, again, like I'm barely qualified to fucking solder, and that just, it all disappeared. Like, you're going to use cheap flux. You can use some Kingbo bullshit. And when you use that, you're going to put that there, and the solder, instead of just instantly just flying right back onto your iron, it's just going to, the solder's just going to stick there. It's going to fly, and it's going to look at you and laugh and say, fuck you. And you know what I'm talking about if you've tried to do this and you failed. Because, you know, everybody remembers their first LCD connector and something like this where it was just frustrating as hell and you just wanted to cry and give up and scream. And because it sucks, you know. When the first time you're doing it, nothing is working the way you want. Come on, stick on there. Or even like now, when it's, you know, the 2000th time you're doing it and you can't even get the thing to work the way you want. You guys know what I'm talking about. You people who've tried to do this and failed, or you people who don't have such a large ego that you forget what it's like to be new at something, you understand what I'm talking about here. So you know. So what I'm going to do is I'm going to clean it again with the alcohol, and then I'm going to go through each pin one by one to see that this shit actually works. So I'm looking for is I want to see that the pins themselves have actually been soldered on. Now, one of the other things that makes the drag soldering process, that process that I did, a lot easier, even though, again, I am a complete and utter hack when it comes to just basic hand soldering. One of the things that made it a lot easier is that it was making good contact. So the contact that the pins are making with the board is going to have a lot to do with it. So as you saw, when I was soldering on the ends of this, when I was putting the ends of the connector on, I was pushing on this really, like I was pushing on that thing really, really hard. As you can see, the board is flexing on the desk when I push. But when you push on this as hard as you can, and then I put the ends on, each one of the pins is actually like pushing against the board a little bit, and that's what you want. You want that tension so that as soon as I go to solder it, there's nothing in between the pin itself and the pad. That's exactly what we're looking for. So I'm going to take my tweezers, and I'm going to take my microscope over to 30x. I'm going to try to take it over to 30x. Now at 30x, I'm going to look at each pin, and I'm going to move it like this. And it's really hard to stay in focus at 30x. I'm going to go 1. I'm going to poke at the pin, and I want to see if the pin moves. So pin 2 moves. However, pin 2 is attached to ground, so I don't care. Pin 3 moves because there's no pad there. Pin 4 moves because there's no pad there. We're going to be putting a wire on that. That's from the Q-tip that I just used. Let's see, you got pin 5, pin 6, pin 7, pin 8, pin 9, pin 10, pin 11, pin 12, pin 13, pin 14, pin 15, pin 16, pin 17, 18, 19, 20, 21, that's out of the microscope, here we go, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. And again, you should be doing this when you do these types of connectors. It doesn't take a lot of extra time to go back and make sure that they're connected. Even if they look connected, sometimes they cannot be connected. I'm actually going to go back and redo that little ground section, even though I know it absolutely, positively does not matter worth a shit and will work just fine. It's going to bother me just knowing that it's there like that. Yes, I am. Everybody here makes fun of me for being an OCD freak on the things and just wasting time on things that don't matter. So let's see if there's also a chance that that was part of the board that was burnt and that I'm just kind of being silly by even trying to fix it. And that it does look like it may be the case. I may just be... Yeah, who am I kidding? That's burned away. There's nothing there. So, but pin 2 on this is nothing anyway. There's nothing even going to it, so I mean... Alright, so now the next thing that we're going to have to do is we're going to run a wire from the backlight end So again, this is something that you can find if you have the board view and the schematic, and I just don't feel like opening it for the 50 millionth time to show you a basic circuit, but this is part of the backlight. This is a bypass capacitor on the output of backlight. We're just going to run a wire from there to there. And again, all these little hairs and this little crap, as long as it's not there when you're actually soldering, you're fine. Like again, I'm not a big fan of using Q-tips because 99% of the time I can use a Q-tip where it's not going to leave shit behind. Sometimes I do. But when I do, I always make sure it's when I'm not actually doing the soldering. I don't want to leave hairs and stuff. I pick them away or blow them away before I actually start soldering. You don't want that inside your joints. With this, I'm going to run a wire from here to there. And this is then going to get dumped into the ultrasonic and toothbrushed heavily to get rid of all that crap, flux and other junk. Okay, so now I got to find my little wires, which are going to be somewhere over here. What's up? 8 o'clock. I may be able to leave earlier if you want to meet and talk or anything. Yeah, so maybe we can meet when I leave at 8. Yeah, that works for me. I'll see you then. Okay, I'm done with that. Now for that fuse that looks like crap. Bye-bye. Now we're going to turn it on, and you'll be able to see that we have a backlight. No shadows on the bottom, which happens when you don't solder the LED returns properly. So that's about that.